Okay, so hello people, today we'll be solving LeetCode daily question, that is 404 sum of left leaves. And before starting that, I would like you to subscribe to my channel and drop a comment and hit the like button. Also, I've started going live. Yeah, I did a live today only in which I solved a bit of Rust questions. And okay, so now let's start with today's question. And from now on, I am thinking of switching the language in which I do the questions. I'll be switching on to Rust. Okay, and in this we begin the root of binary and we will return the sum of all left leaves. A leaf is a node with no children. A lefty leaf is a leaf that is the left child of another node. Okay, for example, we are given 3, 9, 20, 15, and 7. So we need to return the sum of like the left leaves that are 9 and 15, so it will be 24. Okay, but before starting, I'll just switch the language to Java and let like in the easy scenario I'll be doing it firstly in the Java and then I'll be switching on to this. Okay, so let's have a variable answer that is equal to 0, and let's call the function that is find sum, that is with the root, and at the end we'll be returning sum, oh sorry, answer. Okay, now let's write the function that is private void that is find sum with tree node root, and we'll be checking that if root equal to null, I'll be just returning the function. Okay, else I'll be checking that if root dot left not equal to null, what I'll be doing is I'll be answer plus equal to root dot left dot val, and I'll be calling the function for the left side, find sum root dot left. Similarly, I'll be doing that if root dot right not equal to null, what I'll be doing is I'll be calling the function for the right side, find sum root dot right, I guess. And here as I'm checking the condition already, so I don't need this line particularly. Okay, yeah, obviously just comment it out. Okay, and now let's run it. Yeah, and it gets accepted. Now let's submit it. Okay, so it says okay, I'll just have a look. What's the error? Okay, so I made a mistake. The logic should have been like if I need to find the sum of left leaves and not left, no, basically not left nodes. Yeah, I missed that, and I'll be just modifying the code quickly. Okay, now what I'll be doing is I'll be checking that if here, this is just the part which I need to check again, that okay, if root dot left is not equal to null, what I have to check is that if root dot left should also be equal to null, and root dot right dot okay, sorry, root dot left dot right should be also equal to null. In that case only I'll be increasing my answer. Answer will be plus equal to root dot left dot val. Else I just have to call the function for the even if it's true, I'll still have to call the function for the root dot left, and then if root dot right is not equal to null, I'll be calling the function for the right node, that is find sum root dot right. Okay, now let's run it once again. Yeah, and it gets accepted. Now let's submit it. Okay, and it works perfectly fine. Okay, now I'll just quickly code it in Rust also. So in Rust we'll be having some of the conditions that are like argc with like to refer a particular memory location, and as we all know that Rust is a low level language, or let's say it's a middle language, not completely a low level language, so I'll be doing it in this. Okay, So for this, what I'll be doing, let's have a mutable answer because we need to change the answer on the go. That let's start with 0 and let's call the function that is find underscore sum. This uses snake casing, so we need to use this. And here we'll be passing the mutable root, reference of the root. And here we need to write solution find sum, and we have to just return answer. Okay, and in rest, if you miss the semicolon, the last line will be considered as the return statement. Okay, you can also write return answer and then a semicolon, or even if you write this, both work perfectly fine. Okay, now let's write the function find underscore sum, and now quickly let's just pick it up from here. Root option here, a reference to this, and also we are having a mutable answer, so let's answer that is mutable of type int 32. Okay, yeah, as its return time is also i32 basically means integer of 32 bits, which is a signed integer. Okay, if we'll be letting, let's say, some node exists, some node, if it's equal to root, means like the just the condition that if root is not equal to null or root is equal to null, we have to return if some root exists. Okay, we'll be doing let node, we'll be creating a reference to this and we'll be borrowing it from the node dot borrow, node dot borrow. Okay, and now we'll be checking that if let we'll be having because we need to find the sum of left leaves, we'll be checking if sum left exists, that will equal to and node underscore ref dot left, if that means it exists. And if exists, now let's have a let pointer again, that's let left underscore node underscore reference to it, and we'll be borrowing it from the parent node left dot borrow. Okay, and then we'll be checking that if the condition that where we check that if it is a leaf node or not, so for that it should be yeah, and also we don't need parentheses, and if left underscore node underscore ref dot left dot is underscore none, so this is the method to check that if it exists or not. And left underscore node underscore ref dot right dot is underscore none, that means I need to add into my answer, so I'll be using a pointer answer plus equal to root not root sorry left underscore node underscore ref dot value to that. Okay, and else what I need to do, I need to call the function that is solution find underscore sum with and node underscore ref dot left and the answer. Okay, and if not this is not the case, still I need to do the solution find underscore sum to and node underscore reference to the right pointer and with my variable answer. Okay, and I guess this is enough. Now let's run it again. Okay, so it states okay equal to, now let's run it. And root and okay, I made a blunder over here. And mutable answer, now let's run it and it gets accepted. Now let's submit it and it works perfectly fine. And also let's have a look at the memory it has used, that is 2.27 MB, and in Java it's 41 MB, like 20 times more Java uses the memory. Okay, so this was it for today. Thank you for watching.